Flow proof, the type of proof that is used as arrows to show the flow of a logical argument. Statements are connected by arrows to show how each statement comes from one before it. All right, and each reason is written below that statement. So you may have something like, like a family tree kind of thing. Have you seen family trees? That's kind of like a flow proof. Because of this reason, all these other reasons occurred. Okay? That's a flow chart. Now, it's got words in between them telling what's happening, but that's the type that you would see with a flow chart. We don't use that much with math. It's just not as useful. All right, if two lines intersect to form a linear pair of congruent angles, then the lines are what? So the angles are congruent, and two lines intersect. Okay? Then the lines are what? Does anybody know what that means? If they intersect and create a 90-degree angle. Remember what that was from the last class? Very good. Perpendicular. Okay, if two lines intersect and they're equal, they're congruent, then they are perpendicular. All right, if two sides of two adjacent acute angles are perpendicular, then the angles are what? All right, listen again. Two sides of two adjacent acute angles are perpendicular. So the angles are adjacent, they're perpendicular, then the angles are complementary, all right? If two lines are perpendicular and they intersect to form, two lines are perpendicular, they intersect and they form four right angles. If you have one right angle, then you're going to have four right angles when the lines intersect. Is that good? Always. If they showed you only one of those boxes, then you know that all of them are right angles. All right, if two parallel lines are cut by transversal, remember we did the two lines, and cut by transversal, then the pairs of corresponding lines are congruent, meaning this. If the lines are parallel, then corresponding lines will always be congruent, or corresponding angles will always be congruent. Follow that again. If the lines are parallel and they're cut by transversal, then the corresponding angles, no matter what they are, will always be congruent. They'll always be equal to each other. All right, that works the same with alternate interior angles. If you have two parallel lines, the key thing here is that you have parallel lines. If that's the case, then your alternate exterior angles are always going to be congruent. All right, this one's different. Consecutive interior angles. If they're parallel lines, those two angles are going to be supplementary. Does anybody remember what supplementary means? They add up to be how much? 180. Good. So if the lines are parallel, the two consecutive interior angles are always going to add up to be 180. Alternate exterior, if you've got parallel lines, they're always going to be congruent. And that works backwards. If these are congruent, if the alternate exterior angles are congruent, then they're going to be parallel lines. All right, so it may ask you, well, how do you know these lines are parallel? Well, if you find that alternate exterior angles are equal, then you can say because the alternate exterior angles are equal or congruent. All right, so if a transversal is perpendicular to one of two parallel lines, then it is blank to the other. If you have a transversal that is perpendicular to one of your lines. Okay? What do you think it's doing with the other one that's parallel to it? Do you think it's going to be perpendicular to it also? Right? These all have to be 90 degrees. If these are parallel lines, then the corresponding angles are going to be congruent, right? So then it's going to be also perpendicular. All right, given that measure of angle 1 is 118, find the measure of the other angles. All right, one step at a time. Look at angle 2. What do we know about angle 1 and angle 2? Good, because they form a straight line, they're going to equal 180. So if I do 180 minus 118, I'm going to get the measure of angle 2, right? Right, and it is 62 degrees. And the reason behind that is because they form a linear pair, right? Okay, that's why. So the measure of angle 2 is 180 minus the measure of angle 1, which gives you 62 degrees. All right, measure of angle 3. What do we know about angle 1 and angle 3? What kind of angles are they? We don't know they're 90. Does it tell me that? Well, actually, it tells me angle 1 is 118. So, remember that last class? If I was saying it was corresponding, alternate interior, alternate exterior, consecutive interior, what would you say it is? Same location, different lines. They're called corresponding angles. Okay, and because they're corresponding angles, that means that they're equal. So angle 3 is equal to the measure of angle 1, and the measure of angle 1 was 118 degrees, right? All right, now let's look at 5. What do we know about angle 5? A couple of different ways you can figure out angle 5. Anybody got one to give me? All right, Travis?
The same thing as angle 1.
Okay, not the same as angle 1, because angle 1 is an exterior angle. Angle 5 is interior across the transversal.
The angle right above it. I think
Angle 2,
not that.
this one here.
Right there.
Right, it is the same as this one right here. Okay, what do you know about these two angles? Angle 1 and the angle that I made the little dots to. Angle 2 and the other one. They're congruent because they're vertical angles. You remember that? All right, because these are congruent and the little dots and 5 are congruent. We know what the measure of angle 2 is, don't we? Right, we found it. It's 62. All right, these, angle 2 and angle 5, are alternate interior angles. AI. Alternate interior angles. All right. 5 is also corresponding to that dot that I made by 1, angle 1, but it didn't give me that number, so I can't refer back to it. So very good. All right, now let's look at angle 4. What do you think angle 4 is? A couple different answers you could get. The same number you're going to get, but a couple different ways to get it. It is the same as 1, and that is 118. Now, why did you say it's the same as 1? Good. It's alternate exterior angles. All right. You could have said it was the same as 3 and called it vertical angles. Don't care. Either one of those would be correct. See this? All right. So this one's a little harder. We've got a parking lot. Somebody designed it. And we know that line M and N are parallel. So really, I'm just looking at this section here. That's N and M. And they're parallel. So you guys see these little arrows in the center of it? telling you that the lines are parallel. Okay. It's cut by a transversal. And I'm looking for angle 1. All right, angle 1 is there, and this is 80 degrees. What do we know about these two angles? That's all I've gotten. What kind of angles are they? Okay, they're not right angles because one's at 80 and the other one we're looking for. What do we know? Are they alternate exterior, corresponding, consecutive interior, or alternate consecutive interior? So they're consecutive interior angles. Okay, what do we know about consecutive interior angles? They add up to be what? Today, if the lines are parallel, consecutive interior angles add up to be what? They are supplementary, right? And supplementary means it adds up to be what? Very good. All right. So how would you solve? If I have like a variable plus a number equals 180, how do I solve that? How do I get this variable by itself? Algebra. Guys, how do I get a variable by itself? How do I move that 80? Good. Subtract 80 from both sides, you get 100, and that is called the subtraction property of inequality. Is that okay? So you're using a little geometry knowledge and a little algebra to solve the problem. All right, so let's try this. All I'm given is that the measure of angle 6 is 53 degrees. I want you to tell me what the other angles are. So right there, angle 6 is 53 degrees. I've got to find the other three. Okay, so why did you say 8 was going to be the same as 9? What kind of angles are 8 and 9? Vertical. Is it good? So you're going to use all your previous knowledge. You're going to use information about linear pairs. Okay, you're going to use information about vertical angles. And if the lines are parallel, consecutive, interior, alternate exterior, and corresponding. All right. So let's figure out what the next one should be. I'm using properties of parallel lines to find the value of x. And this is a little harder. This is a little harder. You think you can help me out with this? Angle 1. What is angle 1? Anybody? All right, Trev.
What angle is 39? I think.
Angle 39, or excuse me, 39 goes to that angle right there.
129.
Okay, angle 1 is not 129.
Oh.
It's 39 because they're alternate interior angles, and they're going to always be equal if the lines are parallel. All right. So what do we know about angle 1 and the angle with 7x plus 1? What's this? What do they make? 180. They make a straight line, so they're a linear pair. Or supplementary, and they equal 180 degrees. We know measure of angle 1 is 39. All right, and then we combine like terms. 39 plus 1 is what? 40. All right, so you get 7x plus 40 equals 180. Subtract 40 from both sides. 140, and then divide by 7. 20. All right, so x is 20. It's not 20 degrees because we're solving for the variable x. Are you okay with that? We're going to use this knowledge, everything that you've used in the previous past, and you're going to use some algebra and all these new concepts. All right, what's a little box in a corner mean?
90 degrees.
Good. So if that's 90 degrees, what's its corresponding angle here?
90 degrees.
Good. So really it's just 3x equals what? 90, and then divide by 3. 3 goes into 9 3 times. 3 goes into 0, 0. What do we know about these two angles? What kind of angles are they? They're parallel because of these little arrows. They let me know. What kind of angles are on the outside, opposite sides of the transversal? What represents outside? Exterior. And then opposite sides of the transversal is alternate exterior. Okay, what do we know about alternate exterior angles when the lines are parallel? Are they equal or do they add up to be 180? I hear equal and 180. What do you think? What's the note say? What do they look like? They're equal. Don't always go by looks because I promise if I draw it, it's going to be off. All right. Remember if you have variables on both sides of your equation, what you need to do? Move your x's first. Opposite of a positive x, 7x is? You subtract 7x. Bring down your 1. Bring down your 3x. Bring down your minus 50. Then you said you move the 50 to the other side. So you got 51 equals 3x. All right, 3 goes into 5 2 times with a remainder of 1.
Wait.
Thank you. So 3 goes into 5 1 time with a remainder of 2. 3 goes into 21 7 times. So 17 is x. Make sure that's all it asks for. So solve for x. This is refreshing. All right. Angles that make a straight line that are side by side, well, they don't have to be side by side. Side by side are linear pairs. But if they make a straight line together, then they're supplementary angles. They add up to be 180. Remember, opposite angles are called vertical angles. Okay? They're always congruent, period, always. This is stuff you've learned before. All right? So if I was dealing with this, angle A would be what? How many degrees? 30, right? Because, there we go. All right, because they're vertical angles. And then these make a straight line, so it's 180 minus 30. Beautiful. Computer is dying. So this one's 50 and so is angle C. So you remember that concept? I'm not going to spend all your time doing the rest of them. All right, the new one, if the lines are parallel, corresponding angles, okay, corresponding angles, same location, different line, will always be equal. Okay, that only works if the lines are parallel. All right, that only happens if the lines are parallel. All right, and they're going to have little arrows on those lines that are parallel. Okay? Corresponding angles are always going to be parallel. This one's going to be 60 degrees. All right, alternate exterior angles. If the lines are parallel, and that only works if the lines are parallel. But with alternate exterior angles, something different. Sorry, different angles, different types. But alternate interior angles are always going to be equal. Okay, always. If the lines are parallel.